A Chinese robotics company is about to debut a next-gen quadruped robot in Tokyo, and experts warn it could hit the US and Tesla's robot strategy harder than anyone expected. This isn't just another robot dog, it's a signal that China is moving faster in embodied intelligence. But the most unsettling part is what they haven't shown yet. Pudu Robotics has just announced a new quadruped robot lineup set to debut at iREX 2025 in Tokyo this November. The company confirmed it will showcase a next-generation four-legged robot alongside a full product range targeting real-world commercial deployment. This marks the first time a major Chinese robotics firm has used Japan's premier robotics expo as a global launch platform. The announcement arrives as China accelerates its embodied intelligence robot development, positioning itself against established players from the United States, Japan, and Europe. iREX, formerly known as the International Robot Exhibition, ranks among the world's largest robotics trade shows. Held biennially in Tokyo, the event attracts over 700 exhibitors and more than 150,000 visitors from across the globe. Pudu Robotics chose this stage to introduce its quadruped models to an international audience. The company stated the robots incorporate advanced AI systems designed for navigation, decision-making, and autonomous operation in complex environments. Pudu has not disclosed full technical specifications, but emphasized the robots are production-ready and intended for immediate commercial use across logistics, inspection, and service industries. Pudu Robotics was founded in 2016 and initially focused on service robots for the hospitality sector. The company expanded rapidly, deploying over 80,000 robots across more than 60 countries as of 2024. Its product lineup includes delivery robots, disinfection units, and cleaning systems used in restaurants, hotels, and healthcare facilities. The pivot to quadruped robotics represents a strategic shift toward higher complexity embodied AI platforms. Quadruped robots offer mobility advantages over wheeled systems, particularly in uneven terrain, stairs, and industrial settings where traditional robots face limitations. China's robotics sector has grown substantially over the past decade. According to the International Federation of Robotics, China accounted for 52% of global industrial robot installations in 2023. The country installed approximately 290,000 industrial robots that year, surpassing the combined total of the next 5 largest markets. China's government identified robotics as a strategic priority under its Made in China 2025 initiative, directing funding toward research, development, and commercialization. State support has enabled rapid scaling of production capacity and aggressive pricing strategies that challenge Western and Japanese competitors. Embodied intelligence refers to AI systems integrated into physical robots capable of perceiving, learning, and acting in the real world. Unlike software-only AI, embodied systems must process sensor data, make decisions in real time, and execute physical tasks. China has invested heavily in this field, with companies such as Unitary Robotics, Deep Robotics, and Xiaomi all launching quadruped models in recent years. Unitary's Go-To robot, released in 2023, retails for under $1,600, undercutting competitors like Boston Dynamics by a factor of 10 or more. This pricing strategy has raised concerns among Western manufacturers about market viability and long-term competitiveness. Boston Dynamics, a U.S.-based subsidiary of Hyundai Motor Group, has led quadruped robotics development since 2005. Its Spot robot, introduced commercially in 2019, costs approximately $75,000 per unit. Spot operates in industries including construction, mining, energy, and public safety. Boston Dynamics has shipped over 1,500 units globally as of 2024. However, the company's high price point limits adoption outside large enterprises and government agencies. Chinese firms have leveraged lower manufacturing costs and government subsidies to offer comparable functionality at a fraction of the price. Japan's robotics industry faces mounting pressure from Chinese competition. Japanese companies such as Sony, Kawasaki, and Honda have led innovation in humanoid and industrial robotics for decades. However, China's production scale and aggressive market entry have eroded Japan's share in several segments. Pudu's decision to unveil its quadruped lineup at iREX signals China's intent to challenge Japan on its home ground. China's commercial robotics expansion mirrors its success in electric vehicles and consumer drones. Chinese EV manufacturers such as BYD and NIO have captured significant global market share through competitive pricing and rapid innovation. DJI controls approximately 70% of the global consumer drone market as of 2024. Analysts suggest China aims to replicate this model in robotics. In December 2024, China opened its first retail store dedicated to humanoid robots in Beijing. The store, operated by Qingdao Jijiren Intelligent Technology, offers multiple humanoid models for commercial and personal use. Prices range from $1,000 to $28,000, depending on capabilities. Domestic demand for service robots increased 35% year-over-year in 2024, driven by labor shortages and rising wages in urban centers. Pudu Robotics stated the robots feature improved battery life, enhanced terrain adaptability, and integrated machine learning algorithms. The robots are designed to operate autonomously in warehouses, factories, and outdoor environments. The company highlighted its global service network, which includes regional offices and support centers in North America, Europe, and Asia. Something huge just happened in the robot world, and no one saw it coming. Out of nowhere, a Chinese tech giant made a move that could change the entire future of humanoid robots. Factories went into overdrive, corders exploded, and suddenly, even Elon Musk's Tesla project was under pressure. But what exactly did they build, and why is everyone so nervous about it? UB Tech, based in Shenzhen, reported a surge of industrial orders for its Walker S2 robot through 2025. The Walker S2 is designed with an autonomous battery swapping system that enables continuous operation without human assistance. The robot's development represents a move from experimental prototypes to large-scale industrial deployment. The model was first shown publicly in July 2025, followed by a 250 million yuan contract for use in major industrial facilities. Another 159 million yuan deal was announced for a data collection center in Sichuan province, bringing the year's confirmed total above 800 million yuan. UB Tech scheduled delivery of the first mass-produced units for November 2025. The robots are being introduced to real manufacturing and logistics environments, indicating that China's robotics industry is entering an active commercial phase. XPeng, known primarily for electric vehicles, unveiled its humanoid robot named Iron. The robot operates using solid-state batteries and features a bionic muscle system combined with advanced artificial intelligence control. XPeng stated that Iron would be produced in both male and female configurations and aimed at office, retail, and service environments. Mass production is expected to begin before the end of 2026. Meanwhile, Unitree Robotics advanced its own humanoid model, the G1. This robot is designed with force-position hybrid control technology, giving it precise manipulation abilities similar to a human hand. The G1 targets educational and industrial markets and is also slated for commercial-scale production. Together, Iron and G1 highlight how China's robotics companies are developing in parallel across both industrial and service sectors. In the United States, Tesla's humanoid robot Optimus remains under development. Tesla describes Optimus as a general-purpose bipedal robot capable of performing repetitive or hazardous tasks. Elon Musk has stated that up to 80% of Tesla's future valuation could eventually come from the Optimus program. Despite these ambitions, the company's progress has been slower compared with China's industrial rollouts. As of late 2025, Tesla has continued testing limited prototypes and is refining its machine learning strategy. The company has shifted from motion capture training to a vision-based training approach similar to the one used in its self-driving vehicles. Production challenges have also emerged due to restrictions on exports of rare earth magnets from China, materials essential for Optimus's electric motors. Tesla plans to produce thousands of Optimus units by the end of 2025, but no large-scale commercial deployment has yet been confirmed. The robots remain in controlled testing inside Tesla facilities. By contrast, UB Tech and other Chinese firms are already delivering robots for operational use in logistics, manufacturing, and data facilities. This difference shows how China's robotics sector is rapidly moving from research to revenue. China's push aligns with its broader industrial policy, promoting automation and artificial intelligence to upgrade factory productivity and reduce labor dependence. Government support has been strong, with robotics classified as a strategic priority. The Walker S2, XPeng Iron, and Unitree G1 collectively represent the country's strategy to gain leadership in humanoid robotics across multiple application fields. These developments could significantly reshape manufacturing dynamics, cost structures, and global labor allocation. Despite fast progress, several challenges remain across the industry. For all humanoid robots, operational stability, maintenance costs, and safety in human environments continue to require technical refinement. UBTech's growth in sales has not yet produced profitability. The company recorded a first-half 2025 net loss of about 440 million yuan, even as revenue rose over 27.5% to 621 million yuan. High production and research costs remain barriers to mass affordability. Experts also emphasize that humanoid robots still struggle to perform complex physical tasks in unpredictable environments for long durations. In Tesla's case, the training requirements for Optimus are considered significantly higher than those for the company's vehicle software. Optimus's perception and coordination must handle multi-joint motion in three-dimensional spaces rather than a fixed vehicle platform. This makes the scaling of training data and computing power a substantial hurdle. Musk has indicated that the company's artificial intelligence team is expanding resources to accelerate learning models for Optimus, but production readiness remains uncertain. For China's companies, the next stage involves refining reliability and cost per unit while expanding integration with existing automation systems. UBTech's Walker S2 has already been assigned to large industrial sites for assembly and inspection tasks. XPeng is planning controlled deployments of its iron humanoid robots in showrooms and corporate spaces to demonstrate performance in public environments. Unitree's G1 continues to attract interest for training and research use, contributing to broader robotics adoption within China's education and technology ecosystem. Across the global market, these advancements mark the transition of humanoid robotics from prototypes and demonstrations to real industrial roles. As of late 2025, China holds measurable advantages in volume orders and actual deployments. The United States, through Tesla's Optimus and other initiatives, remains a major player, but faces slower commercialization timelines. The competitive momentum underscores a changing landscape in automation. Chinese manufacturers are entering a production phase, delivering hundreds of working robots, while American counterparts remain in testing. Elon Musk's projection that Optimus could be central to Tesla's long-term value will depend on the company's ability to achieve similar industrial penetration. The rapid development and commercialization pace in China illustrate a significant lead in humanoid robot deployment. China's government continues to emphasize robotics integration as part of its manufacturing upgrade agenda. The presence of UBTech's Walker S2 on factory floors, combined with the emergence of XPeng's Iron and Unitree's G1, signals that the next stage of humanoid automation has already begun. Meanwhile, Tesla's Optimus project, though technologically ambitious, remains in a critical phase where testing and scaling must transition into tangible production output to keep pace with the accelerating competition.